Hello, everyone. So today we're going to be continuing our discussion from the other day in Chapter 11, Section 8. We're going to be continuing to look at rational equations. You'll also see these called fractional equations in the book. The reason for that is just because we're dealing with equations now that involve fractions with variables in a numerator or denominator of a fraction. I prefer to call those rational equations, but either way is fine. The meaning of those statements is the same. So we're going to be examining one key concept of them today. You'll remember earlier in the year we introduced the concept of domain, where we described where does it make sense and not make sense to talk about things. Are there any possible values of a variable that would make the expression just not make any sense, regardless of what it was set equal to? One of the most obvious ways this happens is with the concept of something being undefined. You'll also remember that concept from earlier in the year. Undefined is not zero. It's basically saying what you're saying doesn't make any sense. Remember, math is a language, and like any language, if we misplace our words, sometimes we can totally fail to communicate any concept and say something that is just flat out wrong and not making any sense at all. Let's take a look at an example of this right here, and I'll show you what I mean. So remember earlier in the year, we had something like this, 0 divided by 6. So if I take 0 and divide it into 6 equal pieces right here, well, nothing divided into 6 pieces is still nothing. But what happens when I reverse those and take 6 divided by 0? So basically what you're saying by this is I want you to take these 6 parts and divide them into no equal pieces. I want you to divide them into 0 pieces. You'll remember how I said that in class, how it's like showing somebody a desk or a table, giving them a saw and saying, I need you to slice that table into 0 pieces for me. You would just look at them very puzzled, like, what do you mean 0 pieces? How can I take this something right here and turn it into 0 pieces? I basically just can't do anything like that. It doesn't add up. It doesn't make sense at all. So this is not 0. This is undefined, because this mathematical sentence right here doesn't make any sense. It doesn't convey any sort of logical concept. Now we can see very clearly, what if I extend that to an expression with a variable? Is there any way that this expression would not make any sense right here? I can see right off the bat, well, what would happen if x minus 2 turned out to be 0? Then I would have 6 divided by 0, and I'd end up right back here. So what x value does it take to make that true? If x is equal to 2. 2 minus 2 is 0. So I would say this expression would make no sense if x were equal to 2. Therefore, my domain is any x except 2. X is not allowed to be 2. That's the domain. The domain is any value of this where this stuff would make sense. 2 doesn't fall under that category, so 2 is not part of my domain. Does that make sense? Let's continue to look at a few examples here and we'll see a little more clearly what we mean. Let's say I have 8 over x times x plus 6. So what would be my domain here? Where would this make sense and not make sense? Once again, if my denominator is 0, then this expression makes no sense. What's my denominator? It's x times x plus 6. So if that were equal to 0, then this expression just doesn't work. What x values does it take to make this 0? Remember, I'm multiplying two things here. When you multiply two things and get 0, what do you know? What one of them or the other must be 0. So either x is equal to 0 or x plus 6 is equal to 0. If either one of those things were 0, then multiplying them would be 0 as well. This I don't need to solve, it's already 0. And what x value does it take to make this true? X is equal to negative 6. So if I were to plug in 0 or negative 6 for my x, then this expression would make no sense. What does that tell me? X can be anything except 0 or negative 6. There's several different ways to write domain, different notations we use, but don't worry about those for now. Let's just get the concept down. So whenever I'm going to solve an equation for this, I know immediately if I solve it and get 0 or -6, then something's wrong. That solution is not the solution it appears to be because it is not in my domain. It is a value where the expression does not make any logical sense. So by definition, it can't possibly be a solution to an equation. Let's take a look here and see where this actually happens. So this is an example out of your textbook right here. So let's say I have 3 over x minus 2, and I have that minus 6 over x times x minus 2 is equal to 1. And the question, of course, is x is equal to what? What value of x would make this true? Now, we've seen several techniques with how to simplify complicated-looking rational equations like this right here. The easiest way in this case, I don't like having variables in my denominator, so the easiest way is going to be to clear out our fractions. Now, how do we do that? We need the least common multiple of my two denominators right here. So what is the least common multiple of x minus 2 and x times x minus 2? I can clearly see that this one is just this one times x, so my least common multiple is x times x minus 2. It's just my second denominator. So in order to get rid of all of my fractions, I'm going to multiply both sides of my equation times that least common multiple. Why both sides? Because I'm trying to preserve equality. I can't just multiply this side times something and not do the same thing over here. I must preserve equality. So let's say x times x minus 2 times 3 over x minus 2 minus 6 over x times x minus 2. And that would be equal to 1 times x minus 2. So now when I distribute this, I can see how many things will cancel out. So distributing this term times the first, my x minus 2's will cancel. X times 3 is 3x. And when I distribute this whole thing times the second, the entire fraction will cancel out, and all I'm left with is minus 6. On this side, 1 times anything is just itself. So I have x times x minus 2. So of course, this equation looks a lot easier to solve than this one. I'm going to go ahead and distribute my terms here. So x times x minus 2, x times x is x squared. Oops. Sorry, my mouse got stuck. There we go. So when I distribute this right here, x times x is x squared, and x times -2 is -2x. So now I'll go ahead and combine these. I want to get all of my variables together and turn this into a quadratic because I see an x squared there. So I'll get rid of this by subtracting off 3x. And I get -6 is equal to x squared minus 5x. I'll add this 6 to both sides here and get x squared minus 5x plus 6 is equal to 0. And now I have an old-fashioned quadratic equation. This could be solved by any method, but the easiest one appears to be factoring. So I'll go ahead and set up my factors. What times what equals x squared? That's just x and x. That's positive, that's negative. So I have one positive and one negative. What two numbers can multiply to give me 6 and combine to give me 5? That's going to be 3 and 2. Oh, excuse me. Actually, I stand corrected. There we are. This is a positive, excuse me, and that is a negative, so they are both going to be negative. Actually, negative times negative is going to be positive. So what two numbers multiply to give me 6, combine to give me 5? That is going to be 3 and 2. So I have x minus 3 times x minus 2 is equal to 0. Let's double check that that's true. X times x is x squared. Minus 3x minus 2 more x is negative 5x. And negative 3 times negative 2 is positive 6. So I have x minus 3 times x minus 2 is equal to 0. Remember, I'm multiplying these two things. That's understood. When you multiply two things and the result is 0, one of those two things must be 0. That means either x minus 3 is 0 or x minus 2 is equal to 0. In this case, x would equal 3 or x would equal 2. Excuse me. So my two solutions for this, x is equal to 2 or x is equal to 3. So I came up with two solutions that make sense because I was solving a quadratic right there. So it appears two different values of x make this true. But wait 1 second here. This is precisely why it's so important to check our work, to actually check and see whether these two answers really do make this statement true or not. Now, when we were solving typical quadratic equations like this, they always, anytime we got a solution, it really was the answer. But now we're adding one extra caveat to it because we're dealing with fractions right here. And when we deal with fractions, we have to introduce the concept of domain. We say, well, there are certain areas where our answers may or may not make sense. Certain values may not make sense. Let's take a look at this initial problem right here. What is the domain of this equation right here, this expression? Are there any possible values of x where these expressions would not make sense? Either one of them. 3 over x minus 2, for instance. What value could x simply not have, and this makes sense? The value would be x is equal to 2, because 2 minus 2 is 0, and 3 divided by 0 is undefined. Let's look at the second one, 6 over x times x minus 2. Once again, if x is 2, this becomes 0, but also if x is equal to 0. So these two numbers are not in my domain, 2 and 0. They are not values that x is allowed to have, because if it did have those, then this whole equation just goes right out the window. It doesn't make a lick of sense. But 2 was one of my solutions right there, and it is not in my domain. So 2 here is what we call an extraneous solution. Let me say that again, an extraneous solution. What that means is it appears to be a solution, but when you really think about it, it is not. Here's why. 2 solves this form of the equation right here, but it does not solve this form of the equation right here, and for one simple reason, it is not in the domain. These things are indeed logically equivalent, but since we are turning it back to this format where we have fractions, then we have to be careful that those fractions make sense. So we cannot ever plug in a value that would make these undefined, and 2 is one of those values right there. So in actuality, there really is only one solution to this problem, and that is x is equal to 3. That is the only value that really does make this statement true. Let's plug in 2 and see what we get. 3 divided by 2 minus 2 minus 6 divided by 2 times 2 minus 2. In both cases, I don't get 0. I get undefined minus undefined is equal to 1. Does that make any sense? Of course not. So 2 is not a solution. I'm going to cross that out. What happens if I plug in 3? 3 over 3 minus 2. 3 minus 2 is 1, so 3 divided by 1 is still 3. And here I have 6 over 3 times 3 minus 2. 3 minus 2 is 1. 1 times 3 is going to be 3. And 6 divided by 3 is 2. So I have 3 minus 2, and lo and behold, that is indeed equal to 1. So only one unknown value really does make this statement true. So all that you have to do different is when you are converting these and solving them right here, we're converting them for the purpose of making it easier to work with. But this is where we have to take the original form of the equation into account and recognize there are certain values which are restricted from the very beginning because they would make the original question not make sense. So we have to be very, very careful of that going forward. So with that one exception, these are just like the equations we've always solved. But when you get the answer, you must check it. Always define your domain from the very beginning of the problem. Always see if there's any values where the problem would just not make any sense. And write those down, just like we did here. Write down your domain. And if you ever get an answer that is not in your domain, then it is not the answer it appears to be. Only things that are in your domain are allowed. So have a look at these, and of course, as usual, please let me know if you have any questions. I'm always here to help. Thank you.